Hi guys, I figured I'd give you guys some review on some actual Regents exams. I missed the office hours yesterday, so to make up for that, I figured I'd give you some practice questions that you could try out on your own. You can watch my video and follow along and learn something, or you could practice this ahead of time and actually test yourself and then see how you did, and then see the explanations for the ones that you missed if you want to. It doesn't matter how you want to do it. First, let me explain where you can get this January 2020 Regents. It's located online. As you can see, it's actually on the New York State website, and you can find a link to this on the topics page. But here it is, January 2020. There's the actual test, and the answer to all the questions is under the scoring key. The PDF version works pretty well, so you can find all the answers there, or you can just watch my video. Now, just really quickly, let me explain something about every Regents exam. You can break down the questions into questions that are just knowledge in your head you have to remember and memorize, and questions that come straight from your reference table. And it's never the exact same number, but you do have a lot of questions that come right from your reference table. So let me show you really quickly. Unfortunately, the January Regents had a lot of memorization questions, but just look, the circles, all these questions actually are memorization. You have to know information kind of questions. The ones that I put stars next to, those are the ones that are from your reference table straight up. So the first few are mostly memorization. Here's some reference table questions that you'll see starting to pop up here. 11 and 14 and 15 and 16. Okay. Anytime you see a star, it's a straight from your reference table question. Okay. And we're going to go through some of these in a second, but I just wanted to show you that all of the first 50 questions are multiple choice. And I'd say about 30–40% of them are probably reference table. Okay, so just a heads up there. That kind of gives you an idea what your final exam is going to be like, because your final exam is going to have questions that you just have to know it, and there are some where you just have to use your reference table and know how to use your reference table. Some of these you'll see I put an X through because they're not content that I would cover on our final exam, just because we didn't cover all the content, but we did cover quite a bit of it, so that's pretty good. Okay, so there's the first 50. You can see the ones that I crossed out and the ones that I starred and circled. Okay, and so if you want to go through the exam and just see that and look for reference table questions, definitely do them and focus on the whole thing. Okay, so let's start by doing the questions. Let's start with question number 1. This is something that we learned on the very last day of my lesson. So it's, what are 2 pieces of evidence that support the Big Bang Theory? So that's the idea that everything started from a pinprick and has been expanding outward from there. And if you remember from my lecture, it has to do with expansion, and that's always redshift when it comes to the Doppler effect. Things are moving away from us, that's redshift. So it's got to be 1 or 2. And then the other idea, the other evidence behind this is the whole cosmic background radiation. It's kind of like the noise from the Big Bang. So you can always remember Big Bang has something to do with cosmic background radiation. So number 1 is the answer for number 1. Okay. Number 2, we have 2 planets. Relative diameters of the planets are shown, and we see that they're both approximately the same size. So we're looking for planets where we need to figure out which planets these are. And so we want planets that have similar diameters. Okay, so we have to go to our reference table, and you need to go to the solar system data chart, which is on page 15 of your reference table, and we want diameters that are close to the same value. Okay, so you're looking at the equatorial diameter, which is right here on the right side of my screen. Okay, all these numbers, and we want numbers that are very close to each other. Okay, 2 planets. So Mercury is much smaller. It's kind of similar to Mars. So no, let's say Uranus and Neptune. Uranus, 51,000, Neptune, 49,000. That's pretty close to the same thing. So guess what? The answer, thankfully, is number 1. Okay, we didn't even have to go through all the choices there. The answer is number 1. All right, number 3. The motion of a Foucault pendulum provides evidence that Earth is doing what? So that's the idea that it's going to rotate around in a circle. Okay, and as it rotates around in a circle, that's due to the fact that the Earth is spinning on its axis. Okay, and that's every day once 24 hours in a day. And so the Foucault pendulum swings back and forth like this. Okay, you have this pendulum that's pivoting right here, but it goes around in a complete circle. So that's the spin of the Earth. So the answer is number 2. Okay, remember Foucault pendulum has everything to do with rotation. Number 4, which factor is a primary cause of seasonal changes on Earth? Why do we have seasons? What are the reasons for the seasons? And so there's really 2 things for the reason for the seasons. We just have to figure out which one is true out of all these choices. So remember, seasons happen throughout the year. Here's the sun, okay? And we are a planet going around the sun like this, okay? And sometimes planet's over here, sometimes the planet's over here, okay? But we feel different temperatures and we experience different seasons because of the fact that sometimes we're tilted toward the sun and sometimes we're tilted away from the sun. And so in the summertime, which is right here, the northern hemisphere is tilted toward the sun, receives more insolation, more sunlight, more intense sunlight, therefore it's warmer. And so the answer to this question is the tilt. The reason for the season is axial tilt. Remember that. It also has to do with the fact that we revolve around the sun, but that's not one of the choices here. So tilt. Okay. Number 5, let's go over here a little bit. Okay, so we have a picture of the Pacific Ocean. We have these gyres that are the big circulation of the currents of the ocean. And we need to figure out what is causing that. Why is there a clockwise direction of flow up here and a counterclockwise flow up down here in the southern hemisphere? What is that caused by? You could go through the choices and kind of figure out like which one doesn't make sense, or which ones do make sense, if there are any. And the answer to this one is the Coriolis effect. Remember, that's the idea that like something that would be traveling straight is going to curve to the right in the northern hemisphere because the Earth is spinning, and that's that video that we watched a few weeks ago. Okay, so that's the Coriolis effect. Number 6, which changes in surface water movement are likely to occur when vegetation is removed from the side of a hill? So remember, vegetation helps to break up the soil. It's got all these roots, which is going to allow water to get into the ground. Now, if you take away that vegetation, now the ground has no roots, right? It's pretty much solid, flat, not broken up. So water is not going to want to go in. And vegetation kind of holds the water there, all right? It lets it go down slowly. So water is going to want to run off when you have no vegetation. Think of a parking lot, right? So we're talking about infiltration not happening anymore. No infiltration. And if we have no infiltration, then we're going to have lots of runoff. And so infiltration and runoff are always opposites, which means you could have narrowed this down to numbers 2 and 4, or sorry, number 2 and number 3 because they're opposites. But in this case, it's number 2. Infiltration decreases and runoff increases. Okay, number 7. During which phase change will 2 grams of water release 668 joules of heat energy? This is a question that I actually never talked about, and I won't ask you this on the final exam. This has to do with this chart right here called the properties of water. And you'll notice here that it says for we're talking for melting water, it requires 334 joules per gram. Now, if you have 2 grams, that would be 668 joules per gram. Okay, so we're talking about releasing heat, releasing energy. So you're going to look for the word release. There it is. Okay, and we need 2 grams, so that's going to be double this. That's 668. And so the answer to this question is when it freezes. When water freezes, you release a lot of that heat, right? It gets colder, so it's getting rid of its heat. And so the answer to this question is number 2. Again, that's not something I would ask, mostly because I didn't really talk about that. All right. Number 8, we have a chart that tells you about some objects and what they do. This is not something I would ask you either because we didn't really talk about this. We didn't have time to talk about this. You could probably figure it out, though, just based upon some descriptions here. You probably remember that between Mars and Jupiter is this thing called the asteroid belt. And so Z represents asteroids, and that actually gives you the answer because that's the only one that has asteroid number 3 there. The other ones, a meteor is something that burns up in our atmosphere. I did talk about that at one point, so you could have figured that out. X, which is a comet, is something that orbits around the sun like a planet, but it has a very elliptical orbit, and it will come near us every now and then. So the answer to that one was 3. Again, not something I would ask. Okay, so we have a picture of a time lapse of the stars, and they're all circling around a center star right here. We need to figure out what that star is. This should be a really easy one. We talked about this a lot. That guy is Polaris, the North Star, and everything's circling around it because the Earth is spinning on its axis, and it's pointing at Polaris. Okay, the North Pole is pointing at Polaris. So there it is, number 1. Okay, number 10. We have a map of New York State, and we have snowfall, average season snowfall, a lot of snowfall off of Lake Erie over here because of lake effect snow, which comes in like this into the land. Okay, the westerly winds blow into the land over here. We need to figure out what city has the greatest average annual snowfall. So we need to figure out a city that's close to here, okay, according to the map. Now, what you could do for this one is look at your map on page 3 of your reference table and kind of zoom in on that area. Not that you can zoom in with your piece of paper reference table, but I can. So we're looking for cities that are over here on the western side of New York. So we have Niagara Falls and Buffalo, and we also have Jamestown down here. So it's this region. Now, of those, which one receives the most? Well, looks like, let's kind of narrow it down. Right here is Buffalo. Okay. Right here is Niagara Falls. It's right on the tip of the river there where it circles around. And Jamestown, if I were to place it, would probably be somewhere around here. Okay. So if you look at the numbers, it looks like Jamestown probably has the most because it's between 100 and 150. Buffalo would be a close second, probably somewhere in the 90-ish range, okay? And then Niagara Falls would be last. Elmira is not even in the picture. It's way over to the east. So I'm going to say Jamestown for this question. All right. Number 11. Which current has a warming effect on the climate of southeast coast of Africa? All right, so we got to find our map that has our ocean currents, which is right here. I'm zoomed in too much, but it's right here on page 4 of your reference table. And we're looking for the reason this is tricky is because it says the southeast coast of Africa. And Africa is both on the right-hand side of your map and on the left-hand side of your map because it got split by the map, okay? So we're looking for the eastern coast, the southeastern coast of Africa, which is right over here. Okay, here's Africa. The east side of Africa is over here, and we're talking southeast. So that's this current right here called the Agulhas current. Okay, so the answer to this question is number 4, and it warms that current because it's a warm. Well, it warms the coast because it's a warm current. All right, number 12. You'll see the next few questions have some geologic history. I'm not going to give you very much geologic history on your final, but just be aware that all those eras and periods and epochs, which are on page 8 and 9 of your reference table, which we talked about, they're all broken up based upon fossil evidence, based upon all this life on Earth that they discovered through fossils. And so the answer to this question is number 4. Probably not something I would ever ask. Okay, not for your final exam. 13. This is a familiar picture. In fact, right behind me, if you can see it, there's the orographic effect. The orographic effect is caused by mountains pushing air upward. And remember, as it goes up the mountain, there's my mountain, here's the ocean, okay, and here's the air coming off the ocean. That air is forced upward by the mountains, it cools off, it expands, it condenses, and therefore it's going to form clouds over here, and it's going to rain over here, and it's going to be wet over here. So A is the wet side, B is the dry side. So we need to figure out what's compared. The climate at location B is going to be the dry side, and it's going to be warmer because the air sinks back down again and warms up as it sinks. So it's warmer and drier. It's like a desert over there on the B side. Okay. 14. Which important geologic event in New York State occurred just after the Grenville Mountains were starting to erode? This is a question that I'm not going to ask you because it's based upon geologic history stuff. It is strictly based upon page 8 and 9, so it is something that you are familiar with, but you really have to look at page 9 for this one. The Grenville orogeny is right here. The erosion of the Grenville Mountains is right here. And so we're looking for something that happened around the same time period. It's down here in the bottom. And if you look through the choices here, we're looking for just afterwards. And it says just afterwards, the Iapetus Ocean just started to rift and open up. And so if you look right there on the screen, you'll see that's the thing that happened afterwards. And therefore, the answer to this question is number 2. Okay. Number 15, this is something I won't ask you about because I'm not going to ask you a lot of questions regarding the reference table, page 8 and 9, because it's geologic history stuff. So we're just going to cross that one out the list. Again, not going to be asked about. Even this one's not going to be asked about. So don't worry about that one. Which mantle hotspot is correctly matched to its overlying tectonic plate? This is, again, a straight up reference table question. And this one comes from page 5 of your reference table, which you can see on the screen. We're trying to match hotspots, which are those like explosion things, like you can see the Tasmans right there. All right, we're trying to match that up with the plate that's next to it, okay, or what it's underneath of. Tasman hotspot is under the Indian-Australian plate, so it can't be number 1. Canary Island hotspot is over here. Canary Islands are off the coast of Africa. They're over here. They're in the African plate, so it's not that one, okay? St. Helena hotspot is down south of that, and it's also on the African plate, so it can't be that one. Yellowstone, that should have been actually one that popped up right in your mind. Yellowstone's in North America. There it is, and it's on the North American plate. So there it is, number 4. Okay? All right, number 16. We'll go all the way to number 20, and then we'll stop. Number 16, at which location is surface wind speed the lowest? Okay, so high wind speed is where the lines are close. The isobars are closest. We have a big pressure change, so it's going to be really fast-moving air. Low wind speed is where the lines are far apart. Okay, low slope, low wind speed. And so C, the location C, has lines that are really far apart, and therefore the answer is number 3. Okay, A would have the fastest wind speed. All right, diagram here shows a weather instrument, which is known as a sling psychrometer, that is used to determine relative humidity. Relative humidity, as soon as you see any question about it, you should be going to this page, page 12 of your reference table. We're trying to figure out the relative humidity based upon the numbers here. So if you look closely, the dry bulb is 22, and the wet bulb is approximately 14. Okay, so these big lines go by 5. So 5, 10, that's 15. So the number underneath of it is 14. Okay, and you can see here, this is 22. So 22 is my dry, and 14 is my wet bulb. And the first thing you want to do is subtract those numbers. So if you subtract those numbers, you're going to get a difference of 8 degrees Celsius, and we're going to need that number. So dry bulb is 14. We're over here on my reference table on page 12. Here it is, 14. Or sorry, dry bulb is 22. My bad. Don't do that. 22. And my wet bulb difference is 8. And so I'm going over from 22, and I'm coming down from 8. And I get a number that is 40% relative humidity, and that means the answer is number 1. Okay? All right. This question, we're talking about latitudes of the Earth and where the jet streams are located, and you can see all this Hadley circulation. We talked about this a while back. This is related to this page in your reference table, where you have the planetary wind belts. And we're looking at, compared to the subtropical jet streams, these guys, the polar jet stream is at what? Okay, so the polar jet stream is further north because it's like polar, it's colder. So it's at a higher latitude. And if you look at it, it's actually lower in the atmosphere. So it's a lower altitude, higher latitude, lower altitude. And so that's just kind of comparing the two of them and looking at the chart here. Higher latitude, 60 north compared to 30, and it's lower in the air, lower in altitude than this guy is. Okay? Okay, so let's do number 20 as our last question. This is Mount Pinatubo. Mount Pinatubo was a volcano that erupted back in 1991. And when it erupted, it put a whole bunch of gas up into the atmosphere, most of it sulfur dioxide. And the question is asking about what happens to the global temperatures after Mount Pinatubo erupted. So it erupted right here in 1991. And afterwards, you can see the general decrease in the temperature of the atmosphere for approximately 1 year. So right around here, it started to go back up again. And so we have a general decrease for about a year. And therefore, the answer to number 20 is number 1. Okay? Now, again, it would be worthwhile for you to just keep going with this. Go through some of these questions all the way to number 50. Check your answers. Your answers to these questions are online. And you're going to see actually some of these questions on your final exam. So it would be worthwhile for you to do it. Okay? Good luck, guys. We'll talk tomorrow, and hope you're all doing well.